So today we're going to be talking about trigonometry and special right triangles.
First, we're going to be talking about special right triangles. There are two types of special right triangles: 45, 45, 90, and 30, 60, 90. This is the 45, 45, 90 triangle. This is the right angle, and these are the two congruent 45, 45 angles. That means the triangle's interior angle measures add up to 180. Since this is an isosceles triangle, these two sides are congruent, x and x. For a 45, 45, 90 triangle, the hypotenuse is x radical 2. The reason that the hypotenuse is x radical 2 is an equation formula. That equation is x squared plus x squared equals c squared. In this case, c equals the hypotenuse. When you combine these, you get 2x squared equals c squared. Then you put them both under radicals. Then when you simplify, you get x radical 2 equals c, which equals your hypotenuse.
Now we're talking about the 30, 60, 90 special right triangle. 30, 60, 90 triangle looks like this. This is the 30-degree angle, this is the 60-degree angle, and this is the right 90-degree angle. The longest leg is always opposite the 60-degree angle. The values of each of the sides. This side, the long leg, is x radical 3. The short leg is just x, and the hypotenuse is 2x. We know this because of an equation formula. A squared plus x squared equals 2x squared. So a squared plus x squared equals 4x squared, and then we move it down, so it's a squared equals 3x squared because we subtract the x squared on both sides. And then this, when we do radical on both sides, we get a equals x radical 3, which is the value of this side right here.
So now we're going to do some practice problems. Let's start with the 45, 45, 90 triangle. This value is going to be 10. Now, since we know that this value is equal to this value, we can say that this is 10. Therefore, since this is x squared root of 2, we could do 10 square root of 2. Now to prove that, we could do 10 squared plus 10 squared equals 10 square root of 2 squared. So we know that 10 squared plus 10 squared is 100 plus 100, so this is 200. Which equals 10 square root of 2 squared, which gets us 200. Therefore, this works. So now we're going to do another practice problem. This is going to be set to 5 square root of 2. Now what are these two values? We know that it's 5 for both of them. And we can prove this by saying 5 squared plus 5 squared equals 5 square root of 2 squared. So this is 25 plus 25 gets us 50. And then 5 square root of 2 squared also gets us 50.
Now let's do some practice problems with 30, 60, 90 triangles. We have our x. Now let's plug into the equation. The hypotenuse is 2x, which equals 20, and this is x radical 3, so we get 10 radical 3. Now we're going to prove this. 10 squared plus 10 radical 3 squared equals 20 squared. 20 squared equals 400. 10 squared equals 100 plus 100 times 3, which gives us 300. That equals 400 equals 400, meaning it works. Now we have the hypotenuse value. In order to get the short leg, we divide this by 2. So 4 divided by 2 equals 2. This means this is 2, and we can plug this. This now becomes x, and now we can plug this to here
To get 2 radical 3. Let's prove that this is true. So 2 radical 3 squared plus 2 squared equals 4 squared. So 4 squared is 16, 2 squared is 4, and then 2 radical 3 squared is 12. So 16 equals 16, which means that this triangle is complete.
Now we're moving on to trigonometry. The base rules for trigonometry are SOHCAHTOA. TOA. SO stands for sine, which is opposite leg over the hypotenuse. This is the angle we're going for. COS stands for cosine, which is adjacent leg over hypotenuse. TOA stands for the tangent, which is the opposite leg over the adjacent leg. In order to find the sine of a triangle or an angle, you do opposite over hypotenuse. In this case, it would be sine of 4 divided by 5, which gives you 0.139. That is the sine of this. That's the sine of this angle. In order to find the angle measure of this angle, you would do reverse sine, and then you plug in the opposite over the hypotenuse. When you do this, you get the angle measure, which equals 53.13. That equals this angle, so x equals 53.13.
Next up is cosine. Cosine equals adjacent leg over hypotenuse. So for this triangle, we are given the 34-degree angle up here and the 56-degree angle over here on this right triangle. We know that the hypotenuse is 13. We just have to find these two values down here, x and y. So if we were to try to find this value right here, x, we would write cosine of 34 degrees equals, remember, it's the adjacent leg over the hypotenuse. So it would be x over 13. Here, we can multiply both sides by 13. We get 13 cosine 34 degrees equals x. Now we grab our calculator and we type in 13 cosine 34. And our answer is 10.78. So now we know that x equals 10.78. We can now plug that in to right here. Now if we're trying to find the y value right here, we would do cosine of 56 degrees equals y over 13 because it's adjacent leg over hypotenuse. So again, we multiply both sides by 13. We plug this into our calculator. Now we type in 13 cosine of 56. And that will get us the answer of 7.26. We now know that y equals 7.27. Then we plug it in right up here. So this triangle is solved, all the side lengths with the angle measures. Now onto a different triangle. So we have both angle measures down here. We have one leg, but not the other two. So if we were to try and find the hypotenuse length, we would do cosine 41 degrees equals 7 over x. Here, we will multiply both sides by x and get x cosine 41 equals 7. Then we would divide both sides by cosine of 41, which leaves us with x equals 7 over cosine 41. Now we plug it into the calculator, and we do 7 divided by cosine of 41, and that answer is 9.275. So x equals 9.28 because we rounded up, and that is the value of our hypotenuse. Now if we try to find this y value, we could just put cosine 49 equals y over 9.28. Here, we will multiply both sides by 9.28. And we would get 9.28 cosine 49 degrees equals y. Now we plug that into the calculator. We get 9.28 cosine 49, and that equals 6.088. Now we know that y equals 6.09. And just like that, we solved the second triangle.
The next thing we're going to be doing is tangent. We're going to be solving for angle theta. In order to do this, we're going to use trigonometry, this function of tangent. In order to solve for theta in this equation, you would plug into your calculator. You'd do reverse tangent is the opposite of the angle over the adjacent angle. So it would be 15 divided by 10, which equals 56 degrees. That means this angle, this works for right triangles. This angle is, so theta equals 56.31 degrees. That's how you do it. And then you could solve the rest of the triangle because you know this is 90, you know this is 56.31. Then you do 180 minus 90 minus 56.31, which equals 33.69. So this angle, x, equals 33.69. That is how you use tangent in order to solve for an angle measure. You can also use tangent in order to find a side length measure. In this case, this angle measure is 35 degrees and the adjacent side length is 10 degrees. In order to solve this, you would use tangent. So you do tangent of 35 degrees equals the opposite of the angle, the opposite leg of the angle, which is x over 10. You would then multiply this out to get 10 tangent 35 equals x. You can then plug this into your calculator and you can get 10 tangent of 35, which equals 7. So that means x equals 7, which means this side measure is 7, and that would work because this has to be larger than this because this is a 90-degree angle, this is 35, and this has to make it add to 180. So the bigger leg is opposite the bigger angle. The smaller leg is smaller, opposite the smaller angle. So it makes sense, and that's how you do it to get your side lengths.
Angle of elevation. So let's say there's a person right here, and from where he's standing, he looks up to the top of the flagpole. Right here, this angle right here, theta, would be the angle of elevation.
There's also angle of depression. Angle of depression is basically the same as angle of elevation, except the triangle is sort of flipped around. Say, take the person for example. He's standing here, and he's basically like looking down at this angle. So this angle theta is the angle of depression here. So one important thing to remember when dealing with right triangles is that when you have your acute angle and you move to the complement acute angle, the opposite and adjacent sides switch. So for the 57-degree angle, the opposite side is 3 and the adjacent side is 4. Then when you go to the 33-degree angle, the opposite side is 4 and the adjacent side is 3. Another important thing to remember is that similar triangles have congruent trigonometric ratios. So in this example, for 57 degrees, the sine of 57 degrees is 3 over 5. So sine 57 equals 3 over 5. And for this triangle, the sine of 57 degrees equals 6 over 10, which when you simplify it gets you 3 over 5. So sine of 57 degrees equals 3 over 5. For this triangle, this cosine of 57 degrees equals 4 over 5. So cosine 57 degrees equals 4 over 5. And for this triangle, cosine of 57 degrees equals 8 over 10, which when you simplify gets you 4 over 5. And finally, the tangent of 57 degrees in this triangle is 3 over 4. And in this triangle, the tangent of 57 degrees is 6 over 8, which when you simplify gets you 3 over 4. One other thing to remember is that complementary angles, sines, and cosines are flip-flopped. So the sine here of 57 degrees is 3 over 5, and the sine of 33 degrees here is 4 over 5, which is the cosine of 57 degrees. So the sine of 33 degrees equals 4 over 5, and then the cosine of 33 degrees equals 3 over 5, which is the sine of 57 degrees. So cosine of 33 equals 3 over 5. And also, the tangents are reciprocals. So the tangent of 57 degrees equals 3 over 4, and the tangent here of 33 degrees equals 4 over 3, which is the reciprocal of 3 over 4. So tangent of 33 degrees equals 4 over 3. One final thing to remember about trig ratios is that you always round them to 4 decimal places. So for example, if we take, in this triangle, the sine of 33 degrees, so straight out, sine 33 degrees, and we plug that into the calculator, sine of 33, we get 0.5463935. Now when we round that to 4 decimal places, we get 0.5446. And then, just to prove that this is the sine of 33 degrees, we can plug in reverse sine of 0.5446. And when we round that up, we get approximately 33 degrees.